Hello everyone, this is Physics 6.2 Wave Effects. In 6.1 we talked about waves and we explained the two types of waves, the transverse and longitudinal waves. So here in 6.2 we will see how the waves behave. Okay, what are the things that it affect on the waves and how these waves will behave. Firstly, the properties of waves can be studied using the properties of waves can be studied using a ripple tank. Ripple tank. This is the ripple tank. This ripple tank, it's a machine that's used to show how the waves behave. This ripple tank, it consists of, as you can see here, the stand, and here it has water in it, and lamp. Okay, so and also you should take a look here beneath it. So when water will be here, this will be filled with water. When water here it's moving, it makes waves. Okay, this light, it hit the water and it shows the waves here. So here inside this tank, okay, they will put some inside the tank here they will put some obstacles. So it could be like a piece of, let's say, piece of glass or piece of plastic. So it will like hit the waves. It will hit this piece of glass, and some changes will happen to the waves. And these waves or the change in waves will be shown here in this part. Here, I will send you a website. I will send you this link. This link it shows how the ripple tank works. Then some behaviors of waves. Firstly, reflection. As we know, these waves it will reflect, but how this reflection will happen? How this reflection will happen? We will explain here. Firstly, a vertical surface is put in the path of the waves. The waves are reflected from the surface focus here, at the same angle as they strike it. How? As you can see here, these are the waves. The waves are moving in this direction. So here we will have a surface that has the ability to reflect the wave. So here, look what happened. Waves are moving by this direction. It will hit a surface. This surface will reflect it by this direction. If we will draw it here, this drawing, it shows how it reflects. Here it says the surface at the same angle as they strike it. The wave will be reflected by same angle as they strike it. How? This is number one. Number one, it represents the wave direction. Here, this part, it's the surface. Okay, it's the surface. Then here, this one, number two, it's the reflected wave. So now here, when the wave will be reflected, it will make angle. Okay, so here we have two angles, number one, number two. So if we will find, or if we will compare the size of these two angles, we will see it's the same. So angle number one, it's equal to angle number two. This is what do you mean by reflection. Number 2, refraction. Refraction, what do you mean by the word refraction? When the waves bend, okay, or it's bending of the path of the waves. Again, here as you can see, this it's the wave, or these are the waves, okay. Direction of waves, it's by this direction. Here what will happen, let's say here it's air, and here it's what, it's glass. When the waves, it will pass from one medium into another medium. These two mediums, these two parts are different from each other. So here what happened, okay, this was the direction, it must go in a straight line, but when it passed through a piece of glass, let's say for example, what happened, it will start bending, okay. It was straight, but here it's bended. So this, it's what do you mean by refraction, bending of the path of the waves. Explanation of refraction, how we can explain the refraction. First, in a refraction, the wave will bend, and in refraction we will have two mediums. For example, maybe we will have air and glass, okay. Here what will happen, the waves are moving in this way, okay. The oscillation, the waves keeps oscillating up and down at the same rate. So here what we will have, the frequency, it's constant, it will not change, okay. But here, let's say here it's air, okay, and here we will have piece of glass. Now what will happen to this wave, as we explained that frequency, it will not change, it will keep oscillating, it will keep going up and down. So why it's bending if the frequency it's not changing? So what will change here, it's the speed and the wave length, okay. So as the frequency it's unchanged, a decrease in speed must cause a decrease in wave length. So when the speed decrease, what will happen to the wavelength? Also it will decrease. The frequency, it's the same, nothing will happen to it. So here it will keep oscillating, but what will happen when it passes through it, as you can see, the wavelength it decrease. Let's draw it with this one. So here it's the wavelength, here it's the wavelength, number 1, number 2, okay. If you will compare this wavelength with this wavelength, you will see it's smaller. Effect number 3, diffraction. Now diffraction, it differs from the first one and the second one. Here what will happen, the wave it keeps moving in one medium. For example, here it's, let's say it's a light or sound, okay, any kind of waves. The waves, here is the wave, here is the wave, and also here is the wave. The difference between this one and this one, it's what? It's the same wave, but as you can see, a change happened to the waves. Why? Because the waves bent round the sides of an obstacle or spread out as they pass through a gap. This effect is called diffraction. Wave, it passes through what? It spread out, okay, as when it passed through a gap. Here it's the gap. When the wave it passes through a small gap, what will happen to it? It will start spreading. Here also it's spreading, but it's not showing that much. So when the diffraction will be more or less, so this it depends on the size of gap. So the size of gap affect how much diffraction occur. So as much as the gap is smaller, the diffraction will show clearly. It will be better. So diffraction is only significant if the size of gap is about the same as the wavelength. If we will come here, the wavelength, it's what? It's the distance from here to here. This is the wavelength, and this is the gap. This is the length of it. This, the size of the gap, it's about same. It's here. It's close. Okay, it's not same as the wavelength, but it's close. That's why here the diffraction is showing clearly. But if you will compare here the size of this gap with the wavelength, you will see they differ a lot. That's why here the waves, they are not diffracting. Okay, they are not showing that much clearly. Wave evidence. Here are some evidence about the waves. Firstly, waves. What kind of waves? Sound, light, and radio signals all undergo reflection, refraction, and diffraction. So now, how many wave effects do we have? We have 1, 2, 3. Reflection, refraction, and diffraction. All these waves, they go through this three effects. This suggests that they travel as waves. For example, light reflect from mirrors. Okay, so when a light, it will hit a mirror, so what will happen to the wave, to the light waves? Will be reflected. Light bend when it passes through air into glass or water. So here what do we have? We have air, then glass, medium number 1, medium number 2, substance number 1, substance number 2. So when the waves it pass through two different mediums, through different substances, what will happen to it? The light, it will bend. One more thing, sound bend around obstacles such as walls and buildings. Okay, here what do we have? This is what this is how it bends. Sound it bent. Light spreads when it passes through tiny holes and slits. This suggests that light waves must have much shorter wavelength than sound. And the last evidence is some radio signals can bend. round very large obstacles such as hills. This suggests that radio waves must have long wavelength. This is everything about 6.2 wave effects. I hope you will get benefit from it. Have a good day.